Welcome back, and let's get some practice working with those experimental design concepts. Okay, so oftentimes what we're going to do is throw you into a context and see if you can determine these different things. So what is a population, sample, and variables? Okay, and so our first context that we get thrown into is this context where researchers studying the relationship between the length of a stride and walking pace. And the researcher believes that a smaller stride will result in a faster walking pace. And so if you kind of mentally picture this stride, so if you take smaller steps, you're going to walk faster. Does that make sense? We don't know. We'll have to conduct the experiment. But it says identify a population, sample, and any variables. So what I'm going to do here is I'm just going to kind of outline all those. So population, I'm going to talk about a sample. And then I'm going to have the explanatory variable, I'm just abbreviating here, response variable, and then confounding variables. Okay, so a population, a population is specified. Well, none, but presumably we would be talking about humans. Okay, I mean, you could measure the stride of a dog too, and look at the walking pace of a dog, or dogs, I should say. I'm going to say that's probably not what this context imagines. And a sample, well, again, I don't know, so I can't sample all humans, but how many humans am I gathering data on? It doesn't say, but I should probably make that a little bit more narrow and say that this is maybe 100 humans. Okay, just to make a smaller group. Okay, and so there is no correct answer for population and sample here. It's just a whatever you feel like, and if it is unclear, which it won't be on a test, we would allow for you to respond with whatever was appropriate. Okay, but now when we look at variables, there are correct answers here. Okay, so the researcher believes that a smaller stride will result in a faster walking pace. So effectively what we're saying is that smaller stride will influence walking pace. Okay, so the explanatory variable here is going to be what we think causes a change in something else. And so that is going to be the stride length. Okay, and in terms of levels, it appears that it's going to be kind of like it says a smaller stride, and so a stride could vary from like a small stride to a medium stride to a large stride. Now, we would need more details about the actual hypothesis test and experimental design to further specify these. Maybe there's a measure associated to small, medium, large. We don't know that though. The response variable is what we think changes as a result of stride length, and that is walking pace. Okay, and here we don't really know too much about this either, and that's okay. It's okay to work in vague contexts, but it does say faster walking pace. So presumably this is some measure from like 0 to, I don't know, I'm just going to say a very large number, like 1,000 steps per minute. I don't know. Okay, if you did 1,000 steps a minute, you're really trucking. But that would be maybe our walking pace. Okay, steps per unit of time. Okay, and the confounding variable. So now we have to really stop and think. This one's going to take a lot of mental energy. What could influence the response variable, so walking pace, that we are not necessarily controlling for? So I want you to think about that. So what could influence walking pace that we are not necessarily accounting for? One thing I know happens for me all the time is when I am walking with my mom has to take many more steps compared to me because I am taller than she is. So certainly height is a confounding variable here. So taller people usually need less steps. So consequently, is their walking pace faster or slower in comparison to a shorter person? Well, their walking pace is slower, but does that necessarily, and so that's going to influence their walking pace without us controlling for that. So maybe in this design, maybe the research is looking for a certain people with a certain height. Okay, that's how you control for that. And so I might just say the levels here are maybe from, realistically 0 isn't possible, but maybe it's 0 to like 10 feet. Okay, I don't know. I think the tallest person is in the world is like 7'7", but nevertheless. So there we go. We've identified population, sample, and variables. Okay, next one we're going to move through quicker. Well, maybe, maybe not. But here we have a real context. So at Ohio State University, clinicians are, doing this, are recruiting actually right now for this study. So it's been approved and all that, where they're looking at CPAP therapy on blood pressure and heart rate among those people with obstructive sleep apnea, OSA. Okay, so I'll let you just kind of pause this video, or pause it, read the context as you need to. The link is there if you wish to, type it in and go to it. But I want you to use that to see if you can answer the first two questions. What's the population? What's the sample? You will need to click on the link to determine the sample. Okay, and then is it observational study or an experiment? If it's an experiment, what are the control and treatment groups? Try and answer those and resume the video when you're ready. Here are my answers to the first battery of questions that we have here. So the population, it does say right here, the participants of the study are people with moderate to severe OSA. That is the population. Now, typically, the sample is going to be a subset or a piece of that population. And if you click on the link, that's where the 1739 came from. Is that they're hoping to have or recruit 1739 people with moderate to severe OSA. Now, again, they're recruiting, so they don't have any participants for sure right now. Okay, and then is this an observational study or an experiment? And so that really comes down to the point where you have to ask yourself, are there interventions being taken by the researcher? Are the researchers actively manipulating something? And so the answer is yes, because they're giving patients this CPAP therapy, so continuous positive airway pressure therapy. Okay, and also consequently they're dividing that into control and treatment groups, so that even within the experiment, one group doesn't receive CPAP therapy, one group does receive CPAP therapy. Okay, and we have two more questions. What are the variables and their levels? What are some confounding variables? So again, I want you to pause the video and I'll scroll up to the context. What are the explanatory response variables and what are some confounding variables? Okay, pause the video, try it out, resume when you're ready to hear the answer. All right, so here are the variables that I have. So the explanatory variable, certainly that one is very clear cut. It's the CPAP therapy. So, and we're seeing whether or not that influences the symptom severity or the OSA symptom severity. Okay, so and presumably there's some scale to measure the sleep apnea, but it isn't specified here in detail, but it does say to a lesser degree, so that leads me to believe that the levels might be something like mild to extreme for the response variable. Okay, some confounding variables that I thought of, and again, these you could come up with an extensive list, I'm sure. Certainly could be some environmental effects, air quality of the house, normal like living routine. Maybe you're using, you have a different diet, that sort of thing. That might bleed into culture a little bit. So maybe there are some cultural practices. Maybe they, do yoga before bed and are very calm. And so versus a person that is very stressed going to bed. So they might have, experience their sleep different because of cultural aspects. Or maybe sleep schedules in there too, and they sleep on a different time because of certain events going on in their life. So those are all different confounding variables. Okay, so we got some practice just working with identifying populations and samples and variables. So we'll make use of this going forward.